Okay, good morning again, everybody. Let's start with some housekeeping matters. I now have finalized my schedule for the semester, so I am now ready to declare my consultation hours or my office hours. So I decided to put it at 1 to 2 p.m. Monday to Friday. So you can catch me on Microsoft Teams. Uh, sorry, not 1 to 2, but 1 to 3 p.m. from Monday to Friday. So total of 10 consultation hours for a week. So I will share with you guys a permanent meeting link. So para dun sa consultation hours, it will be also via MS Teams. But yeah, yun na yung gagamitin natin for the entire semester. But if you have some questions outside of these hours, of course, you can just give me a quick chat or an email. So I try to respond as soon as I can. So kung gusto niyo mag-hangout lang or wala kayong ginagawa, gusto niyo nang may makakausap, be it math related, acad related or whatnot, anything under the sun basta gusto niyo nang kausap. So just drop by MS Teams 1 to 3 p.m. from Monday to Friday. So pwede niyong humingi kayo ng advice about your career as a student, as a math student. So yeah, we can talk everything under the sun. Pero prioritize muna natin yung academic questions. Pero if nobody is asking any acad question, then pwede tayo mag-chit-chat lang from 1 to 3 p.m. from Monday to Friday. Okay? So I'll share the link later um, via Canvas or kung hindi pa kayo member ng kung wala pa kayong UP email hanggang ngayon, so at wala pang Canvas account, I can send my consultation, the meeting links for my consultation hours via email. Okay. So again, that's 1 to 3 p.m. Monday to Friday. But if you're not free during those times, you can also arrange a schedule with me. So email nyo lang ako or i-chat nyo lang ako. So whatever you need, I'll try to be there for you. Okay. So happy Thursday morning. It's almost the weekend. So that means we need to finish the study guide for week number 3 para hindi ko na pahirapan yung lab instructors nyo on Monday. So let's try to finish it. Though masaya yung naging meeting natin last time, so baka magtanong-tanong uli ako. So ganitong gawin natin sa recitation, guys. So sorry, hindi ko na foresee yung problem. Some people might not have their microphones on. Tapos sinabi ko yata last time, mas malaki yung points na nagre-recite verbally. So what we'll do right now is paunahang magtaas ng kamay. So raise your hand. Use the raise hand button in MS Teams if you want to recite. Whoever raised their hand first, sila yung i-recognize ko. And then you can either unmute yourself or put your answer in the meeting chat. So equal na lang yung points nila. Pero para hindi ako dagsain sa chat, so taas muna ng kamay tapos bago sumagot sa chat. Okay? Now let's see. So these are just bonus points. So don't worry if you can't participate or if you don't want to participate, it's fine. It's just extra incentive for those who want to participate in the class. Okay. So last time we talked about quantified predicates, which is a more detailed or a more inner look at propositions. Wherein now propositions that we are considering have 3 parts. Number one, they have a term or a subject, which could be a single term or a single variable, or it can also be multiple variables coming from different domains. Number two, it also has a predicate, which is basically a claim of something being true, or basically a proposition that holds for a specific term. So we usually denote them by, say, P of X. So this is statement P about the variable X. So ngayon, may subject na yung mga propositions compared to what we considered in the past, wherein propositions are sort of blanket statements. Ngayon, may specific subject or subjects na siyang pinapatungkulan. So and then the entirety of the entirety of that statement is what we call a predicate. And then the third part would be a quantifier. And we have two types of quantifiers. We have universal quantifiers, which means that the predicate is claimed for all possible elements, all possible values of the subject or subjects. So we are claiming the predicate to be true for all elements of the domain. Okay. And then number two is an existential quantifier, which only claims that the statement will hold for at least one element of the domain. So the truthfulness or falsity of these quantified arguments are actually quite intuitive. If you have a universal quantifier, it will be true if it is true for everything in the domain, and it will be false if you can find a counterexample, one element of the domain that will make the predicate false. Now, for existential predicates or existentially quantified predicates, it is sufficient to give me an example of an element of the domain that will make the statement true. Pagka nakahanap ka ng isa, then automatic the statement becomes true. But if you will be able to if you will be able to show that the predicate cannot be true for any element of the domain, then the existentially quantified predicate is false. Okay, so basically yun yung ginawa natin last time. And we have a couple of exercises where we translated English statements or informal statements into symbols. Okay, now let's see. I think we stopped before example exercise 12. So exercise 12, we are given the domain, set of all real numbers, and we have the statement. There exists an x in A such that x squared is -1. So how do we show that this statement is false? So anybody who can provide me a proof na false itong statement na to? Oh, bilis. Yes, Marnie?
Good morning po. Rinig
Yeah,
po
good
ba
morning.
ako?
Yep.
Justify why this statement is false. Um, Getting the square of any real number will result to a positive number. So since there is no element in A that satisfies the statement, there exists for some x in A such that x squared is equals to -1. Therefore, it is false.
Okay, great. Thank you, Marnie.
Yun lang
That's
po.
perfect. So, kasi sabi nga ni Marnie, kapag ka meron kang kahit anong real number, so because A is equal to R, so kahit anong real number, pag in-square mo, ang sagot ay laging non-negative. So, it would be impossible that you can find a real number such that its square is equal to -1. So, therefore, dahil walang element ng domain na magpapatrue dito sa statement about X, then the statement or the existentially quantified predicate is false. Okay, thank you, Marnie. Oh, and then by the way, as usual, pag nag-recite kayo verbally, please comment on the meeting chat para doon ko na lang sila itatabulate. Okay, so some more examples. I think example 13 shows how quantified predicates can be compound. So let's see. We again use the predicates T about X, meaning X is divisible by 3. And S about X is a statement X is divisible by 6. So gusto nating illustrate in these two examples na posible ring maging compound yung mga predicates. So for instance, if you want to say some numbers divisible by 3 are divisible by 6, if you want to translate it into symbols, so tingnan natin, mukhang kailangan natin pa itong i-translate into a more formal statement na madaling i-translate literally into symbols. So some numbers divisible by 3 are divisible by 6. So therefore, it is claiming that there exist some elements of the domain who are divisible by both 3 and 6. Okay? So yeah, and that is what is the lengthy statement here. So, ibig sabihin, may mga number daw. So, that means we know that this is an existentially quantified predicate. So, we write there exists. Okay. And then, meron daw mga numbers na divisible by 3 at divisible then by 6. So, our predicate would be T of X and S of X. So, this just illustrates that posibleng compound yung mga propositions na nandun sa predicate. Okay. Now, okay. Oh, by the way, since this is an example of a statement where the domain was not explicitly mentioned. So, can you guys give me the most sensible domain to consider for illustration 13, ano yung set A ko na domain? Yung pinaka-sensible. Though it's subjective, pero yeah, I think you will get what I mean. Anyone? Ano kaya yung ideal domain for this illustration? Yes, Victor Luis.
Sir. Hello.
Hello. Yes, go Victor.
Um, the set of all real numbers, sir.
Okay, yeah, katulad din ng suggestion ni Esther. Okay, pwede yung set of real numbers because as we have mentioned that yung domain pwedeng napaka-broad niya. Pero there is a smaller set that would be a better domain than R, right? Let's see, Mary Mitzi. Yan na naman yung dalawang Marys, no? Mary Mitzi, ano yung suggestion mo?
Ako po, ang suggestion ko po is yung commonly na ina-apply ng divisibility rules, which is positive integers po.
Okay, great. Yeah, that's actually what I'm looking for, the set of all integers, okay? So kasi kung ilalagay niyo yung set of real numbers, unfair dun sa mga rationals at saka mga irrationals because they cannot be divisible by 3. Kasi by definition, yung divisibility ay nag-a-apply lang sa mga integers. So although we have said na posibleng malaki, so still Victor and Esther's answer could be also considered as domains. Pero kasi meron silang ibang mga elements na hindi nag-apply yung divisibility rule. So medyo magugulo yung discussion kasi by them magiging vacuously true yung mga statements na to kasi hindi sila or hindi define yung divisibility for them. So in such an instance, kailangan nyo ring tingnan yung context ng problem. So para saan ba design yung mga statements? So in this case, designed lang yung mga statements, so yung dalawang predicates for those elements X for which divisibility is well defined. And true enough, as your classmate suggested, posibleng mas ideal na domain yung set of all integers kasi sa kanila nakadefine yung divisibility rules. Okay? All right, so another example is this, illustration B. Some numbers divisible by 3 are not divisible by 6. So meaning, some numbers, sa math, pag sinabi nating sum, sufficient na may isa. Okay, so sum is synonymous, at least in mathematics, as there is at least one, or there exists some number, or there exists a number. Okay, so sa English, siguro ang main connotation natin sa sum, merong mga elements. So merong parang suggestion na there is more than one. Okay, pero sa math, when we say sum, posibleng isa lang. Okay, so this is an existential quantifier. So some numbers divisible by 3 are not divisible by 6. So meron daw mga numbers na divisible ng 3 pero hindi divisible ng 6. So you can symbolize it this way. There exists an x such that t of x is true and not s of x. So meron mga x's na divisible by 3 at hindi divisible by 6. Okay. So again, this is a very compound proposition. Yung isa may negation pa. So all the rules that you already studied in the previous weeks and your previous classes will still apply here kasi nadagdagan nga lang ng panibagong rules yung nilalaro nating game of logic. Meron ng rules na nag-apply for quantifiers. Okay. Now, some more illustrations. So illustration 14. So ang predicate natin ay z of x. So the statement z about x is that x is an integer, while q about x means x is a rational number. And then we want to translate the following into symbols. So example A, every integer is a rational number. So ibig sabihin daw, lahat ng integer ay rational number. So perhaps it's easier to translate it first into a more detailed English. So every integer is a rational number. Kapag ka daw integer, automatic siya ay rational number. So here I can see that if x is an integer, then it is a rational number. So kapag ka medyo blanket yung statement or generic yung statement, so it could be translated into a conditional statement. Kasi lahat daw ng integer ay rational, so it is necessary for every integer to be a rational number. So when we translate it using the predicates z and q, we can say that this looks like for all x, okay, ang z of x implies q of x. All right. Now, illustration B, 5 is an integer. So this is an example wherein the subject is a constant. Hindi siya isang variable or isang placeholder. So kapag ka ganun yung statement, dun sa predicate, papalitan nyo lang yung variable by the constant value. So here we're saying that 5 is an integer. So in symbols, this is just z of 5. Okay? Yung x, pinalitan ko lang ng 5 kasi explicitly stated dun sa sentence kung ano yung subject. Ano yung constant subject or constant term. Okay. Example C, some rational numbers are integers. So, in this particular case, meron daw mga rational numbers na integers din. Okay. So, in symbols, you can say there exists an x such that it is both a rational and an integer. So, q of x and z of x. Right? Check ko lang kung tama yung sagot ko. Yes, yun yung intended. Kasi pwede ko rin siyang isulat na, or anyway, wag na natin pa-komplikaduhin. So, yeah, ganito natin siya translate. Okay, part D, no integer is a rational number. So, any suggestion? How can I translate D into symbols? Though mahirap pala siyang gawin sa chat, no? Bawal tumingin sa page 30. So, no integer is a rational number. Parang natawag nga kita Mary Mitzi, so dun ako sa next. Mary Rose.
Hello po sir, rinig po ba ako?
Oh, yes. Hello.
Sir, pwede po, mag-try po ako.
Okay, good. Yeah, go ahead.
For all elements of x such that not z of x po.
Mm-hmm.
Implies q of x.
Okay. Yeah, let's analyze your answer. Thank you. So, yeah. So, for all x, not z of x implies q of x. So, no integer is a rational number. So, ibig sabihin, let's see if it corresponds to your symbolic answer. So, for all x, kung hindi daw siya rational, kung hindi siya integer, automatic daw na rational siya. But is that the spirit of the statement? Mukhang medyo hindi. May problema yata dito. So for all x, not z of x, hindi siya integer, implies rational siya. Pero no integer. Okay, I think it needs some revision, but thank you for trying, Mary Rose. So don't worry kung hindi eksaktong tama yung sagot nyo, you still recited, so you still get the points. Thank you for trying. Let's see some other hands. Kelvin.
Hello ba sir, rinig po ba?
Yep. Hello, good morning.
I think it's the other way around po. For all
Okay.
elements of x, yung bali yung negation po is mapupunta dun sa q imbes na sa z. Kasi po parang nakita ko po na ini-imply niya na kapag po given yung integer, ibig sabihin is hindi po siya rational kasi po wala pong integer na rational.
Okay, yeah, thank you, Kelvin. Yeah, I think that is the more appropriate symbolization for this particular statement. Kasi as Kelvin suggested, na walang integer na rational number. So kung walang integer na rational number, ibig sabihin kung integer siya, automatic automatic hindi na siya rational number. So, yeah, I think that's correct. So kung integer siya, automatic hindi siya rational number kasi walang integer na rational. So for all x, z of x implies not q of x. So thank you. Let's see. Okay, there we go. Okay, let's see part E. Some integers are not rational numbers. Oh, KDL? Oh, sorry, hindi pala.
Sir,
Hello, yeah.
apa. God na lang po, sir.
You want to try example E?
Yes, sir.
Sorry, yeah. Okay.
Yes, sir. There exists x such that z of x and not q of x.
Okay. Oh, thank you. Yeah. Let's see. Some integers are not rational numbers. So, ibig sabihin, ang quantifier either exists, so that's correct. Meron daw mga integers na hindi rational numbers. So, dapat si x ay maging integer, okay? Tapos hindi siya rational. So, I think that this is correct. Okay, so I think you guys are getting the hang of it. Medyo tricky lang dun sa mga conditional statements, alright? So medyo kailangan yung i-analyze kung ano talaga yung spirit. So nakita nyo hindi ganun ka literal yung translations, hindi siya parang Google Translate lang. So nangyayari is kailangan natin siyang talagang basahin yung statement and try to understand it, okay? Right, so sige, may isa pa. Example 15. Using the preceding predicates, translate the following into symbols. Some rational numbers are not integers. See who want to answer. Renato Jr. Gusto mo try yung exercise 15?
Good morning po, sir.
Morning.
Sir, for some x, q of x and not z of x po.
And not a z of x. Okay, thank you. Let's see. So some, so there exists. Dapat meron daw mga numbers na rational, so q of x is correct, and not integer, so not z of x. Okay, great, perfect. So thank you. So yun yung yes.
May
Si Mary?
question mo po ako.
Go ahead.
Kapag po ba universal statements, palagi pong implication and existential po, lagi po bang conditional, conjunction po?
Kapag universal statement ay laging conditional. So yeah, there are actually parang ganun yung nangyayari. Pag blanket yung statement or universal yung statement, more likely magiging implication siya or kung nagiging condition siya sa isang particular assumption about all elements of set satisfying that property, pwede mo siyang i-translate into a conditional statement. Though hindi conditional statements lang yung posibleng translation niya into symbols kasi 'di ba meron kayong laws of equivalence na natutunan dati. So merong rules of equivalence na nag-apply para sa conditional statements. So pwedeng yun yung alternative translation into symbols. Pero if you look at, say, I guess example A, so blanket yung statement na every integer is a rational number. So of course, there are other translation to it. Pero yung mas recommended na translation, or actually this is also the first translation that comes into my mind. Pag inanalyze ko yung situation, every. So most likely implication to. Kasi nag-hold siya sa lahat. Pero kailangan may masatisfy muna siya. So para daw sa lahat ng number x, right? Nagiging rational siya or automatic yung pagiging rational siya dun sa pagiging integer niya. So for every x in the domain, it being rational is conditioned on being an integer or can be conditioned on being an integer. So parang nagiging prerequisite yung pagiging integer or enough na prerequisite yung pagiging integer para maging rational siya. Kasi the statement will only hold, siguro ito pa yung isang paraan para mas madaling makita. Yung statement ay kiniklaim para sa lahat ng integers. Tapos hindi siya para sa lahat ng elements ng domain kasi it says every integer. So what statement A is claiming is true only for integers. And it says na kapag ka daw integer siya, automatic na rational siya. So ibig sabihin, kung integer siya, that is z of x, magpa-follow directly na siya ay rational. Okay. Now, meron din naman yung negation naman, posible rin siya maging conditional. Like example D. No integer is a rational number. So again, the statement is being claimed for integers. Okay. Walang integer. So mukhang yung statement D is a statement about integers. So dapat maging integer siya muna. So that's why being an integer or z of x is the antecedent. Kasi para mag-hold yung statement, dapat true muna yung z of x. Tapos walang integer. So ibig sabihin, kung integer na siya, imposible siyang maging rational number. So that means, mag-i-imply yung not key of x. Pero again, these are not the exclusive translations. There could be some other translations na iba yung pagkaka-phrase symbolically. Pero via rules of equivalence, posible natin silang masulat in this form. Okay? So don't worry, i-check naman namin lahat ng possibilities. So if you have a different translation which is equivalent to what we are looking for, then that is perfectly fine. Okay?
Thank you po, sir.
Okay, welcome. Naririnig niyo ba yung ulan? Nag-start na yung ulan dito. So, hopefully hindi masyadong affected yung audio. Okay. Now, let's go to translating statements. Again, this is still the same exercises that we are doing. Pero kasi gusto namin talagang i-emphasize yung pagka-translate. So here we are translating informal statements. I think tinawag nilang informal statements dito yung English sentence, okay, o yung description. And then we want to translate it into a formal one. When we say a formal statement, siya yung statements na nag-involve ng symbols or ng quantifiers and the predicates. Okay, so let's look at example 16. So illustration A. All even integers have even squares. So if we want to translate it into formal language, kailangan ko munang i-define yung mga sets na gagamitin ko kasi wala tayong standard notation for the set of integers. For the set of even integers. So we can say E is the set of even integers. So kasama dun sa translation into formal language, yung pagde-define ng mga hindi usually used or hindi well-defined sets. Tulad nung even, wala tayong standard notation for them before. But now we can use the set E. So ito na yung gamitin natin for even. So let E be the set of even integers. Tapos sabi niya, for all even integers, even din daw yung squares. So that is in formal language, you can say for all x in E, x squared is also in E. Okay. So dito pala, ang kinoconsider pala nung notes na formal language ay para ring English pero gumamit tayo ng mga symbols. Not necessarily gumagamit tayo ng mga predicates. Okay? O yung mga statement T about text, statement S about text. So posibleng wala na sila dito. Okay? Pero kung gusto kong i-test ang truthfulness nito, mukhang kailangan kong, or minsan, kailangan kong gumamit din ng predicates para mas madali silang i-analyze, especially if you wanna use a truth table to check the truthfulness or falsity of these predicated statements. Okay, let's try B. There exists a continuous function f such that f is not differentiable. So, kailangan kong i-define ano yung set ng continuous functions at ano yung set of differentiable functions. So the first statement in the formal translation is the definition for these sets. So we let T upper 0 be the set of continuous functions, and D be the set of differentiable functions. And then in symbols or in formal language, the statement says there exists an F in C upper 0 such that F is not in D. So makikita nyo backwards pag translate siya into informal language, you can say there exists a function that is continuous but is not differentiable. So basically symbolization or translating an English sentence into a semi-mathematical sentence, which we will refer to as a formal sentence. Okay, let's try exercise 17. Okay, who wanna try problem A? Okay, Alisa? Gusto mo bang try yung problem A? Go, Alisa. Okay, mag-send siya sa chat. So, okay, no problem, Alisa. So, Alisa said, let R be the set of positive real numbers. And for all x in R, x squared is an element of R. Okay, I think that is great. So, kaya lang, medyo, Alisa, medyo repetitive yung paggamit mo ng set R. Kasi we already use the set R to be the set of all real numbers. So I guess you need to use a different variable for the set of positive integers. But I see what you're trying to get at. Pero kailangan maging mas specific tayo or maging mas how do you call it? Dapat mas specific at mas careful tayo sa paggamit ng notation. So for instance here, I will rather let say P be the set of all positive real numbers. Okay. And then I can say for all x in R, okay, kasi sabi ng statement all real numbers. So for all x in R, x squared is positive. Okay. Or you can say for all x in R, x squared is greater than or equal to 0. Pwede rin yun instead of defining a different element by defining a set P. Okay. So either way, that's fine. Okay. Now, how about statement B? No real numbers have squares equal to -1. Okay. Yes, Amos and Jace.
Ay, hello po, sir. Rinig po ba ako?
Yep. Go on.
Jace na lang po. So, ano po, let R be the set of real numbers. So, for all x element of R, x squared is not equal to -1.
Okay. Thank you, Jace. Yeah, that's correct. So, okay, yun nga lang. Pagka na-define na before or usually yung notation for the set that you will use, there's no need for the definition of that set. So pwede mo nang simulan yung statement B just this way. For all x in R, kasi alam na natin yung R siya yung set of real numbers. So for all x in R, x squared cannot be equal to -1. Okay, so that's perfect. And then how about example C? There is a positive integer such that m squared is equal to m. John Rensis.
Hello, sir.
Hi, good morning.
Good morning po. Let R be the set of positive integers. Then, there exists an x in R such that m squared is equals to m.
So let R be the set of positive integers. And then
there exists
an x
an x in R such that
Okay, thank you, Jen Rancis. Yeah, that's perfect. So yeah, medyo again careful with the use of symbols. So pinili niya na R pa rin yung tawagin niyang set of positive integers. So that's fine. Pero pag sinulat nyo, distinguish natin siya from the set of real numbers. Ako pa yung nagkamali. No? So dapat hindi double struck yung set R, hindi siya nakabold. So yeah, for all x in R, m squared is equal to m. Okay, so that's good. Now, some more illustrations. So here, ito naman yung translation.
Question po. I have a question po.
Okay, go ahead, Daniel.
For C po. Since m squared is equal to m uses a variable, the variable m po, should we not use some m in R? Question.
Okay, thank you, Daniel. Yeah, that's right. So dapat nga m in R such that m squared is equal to m. Thank you. Baka yun din yung sabi ni John Renzi, sorry, na typo lang. So, dati pag face-to-face, pag may mga ganyang eksena, ang excuse ko palagi ay tinitingnan ko lang kung nakikinig kayo. At least alam ko nakikinig kayo. Pero yeah. So thank you for noting that. Okay. So moving on to example 18. So for example 18, gagawin natin yung pakabila naman. So we want to translate formal statements into informal ones. Okay. Dito na rin pala yung solution. So walang recitation for that. So the formal statement is there exists an x in R such that x squared is equal to 2. So when we translate it into informal language, so that means there exists a real number whose square is equal to 2. And then second statement, for all x in P. So kapag ka double struck yung P, we'll use it for the set of all prime numbers. So yung double struck P, set of prime numbers. Kapag ka curly P, siya ay set of positive real numbers. What else? Or pwede rin sigurong R plus para sa set of positive real numbers. Kung positive integers, pwedeng Z plus. Kung negative integers, pwedeng Z minus. Okay? So, number sets, tas lagyan nyo lang ng superscript na plus or minus para kunin lang yung mga positive at saka mga negative elements nila. Kung gusto nyo isama si 0, pwedeng bilugan nyo lang yung superscript. So yung Z plus circle, this is the set of all non-negative integers. Z to the minus encircled. So ito naman ay kasama si 0. Kaya siya encircled para i-denote yung 0. So ito naman yung set of all non-positive integers. So yeah, some additional notations for us. So in view of that, so statement B, for all x in P, x is odd or x is equal to 2. So that means for any prime number, either it is odd or even. Or in a more informal language, all prime numbers are either odd or is equal to 2. Okay. Though parang itong statement na to ay pwede mo rin gawing conditional statement, right? Or not just like a disjunction. So yun yung sinasabi natin kanina na posibleng maraming translation yung isang possible statement. Okay? So you can try exercise 19 later on your own. In the interest of time, I want to go to the next topic, negations of quantified statements. So remember, pag negation ng quantified statements, gusto nating kunin yung proposition which has the opposite truth value compared to your original proposition. So pag nag-negate tayo ng, halimbawa, meron kang proposition P, ang negation niya ay not Q. Right? So, ang nangyayari ay not P. Binabaligtad natin yung truth value niya. So, ganun din sa predicated or sa quantified predicates. Gusto nating kunin, pag sinabi nating negation ng quantified statement, kukunin natin yung statement which has the opposite truth value as that of your given statement. Okay? So, but in general, yung mga quantified statements, they can fall under 4 categories. So number 1, for all x, P of x is true. So everything has the property P. Statement B, something has the property P. Statement C, nothing has the property P. And statement D, something does not have a property P. And then the negation of a quantified statement will fall under one of these categories as well, as we shall see later. So let's see muna specifically how do we negate quantified statements. So if you have a universal statement, tapos gusto mo siyang i-negate. So we want to see what's the negation of the statement for all x in A, P of x is true. So ano yung ibig sabihin niya? So remember, ang ibig sabihin nito ay totoo siya sa lahat ng P of x. So for every element of the domain, pag sinubstitute ko kay x, magiging true yung statement. Okay? So paano natin, ano yung statement which has the opposite truth value? So I hope you see na para maging false ito, kailangan may makita akong isang element ni x na hindi totoo si P. Tama? So again, this will be true kung totoo siya sa lahat ng element ni A. Magiging false siya, which is the opposite truth value ng true, kapag ka may nakita akong isang x na hindi totoo si P of x. Saka siya nagiging false. So basically in symbols, may nakita akong element ni domain na hindi totoo si P is this guy. There exists an x in A such that not P of x. And we call this, or this is actually the negation of your universally quantified statement. Kasi again, yung universally quantified statement totoo sa lahat ng x si P. So kung gusto mong kunin yung baliktad na truth value, ibig sabihin dapat may mag-exist na isang element ni A na hindi totoo si P. And that will serve as the negation of our statement. Okay? So there exists an x in A such that not P of x. So basically, ang nangyari ay pag ninegate mo pala yung for all, nagiging there exists. Pero dapat ininegate mo rin yung predicate. Kaya meron kang not P. So basically, you can think of the tilde operator coming inside of your argument. Papasok siya dun sa dalawa. Kailangan kong i-negate yung universal, magiging existential. Kailangan kong i-negate si P, magiging not P. Okay? Let's probably... Okay. And actually, it also works the other way around. So, ito na pala yan, na-skip ko siya. Kung gusto naman nating i-negate ang isang existential quantified o isang existentially quantified predicate, again, papasok lang yung not o yung tilde dun sa buong quantified predicate. Tapos, ibig sabihin, kailangan kong kunin yung not there exists. Hindi, walang nag-exist. So, ibig sabihin, magiging for all siya. Okay? And then, ininegate ko yung statement P, makukuha yung not P. And why is this true? Remember, this existential statement is true kapag ka may nahanap akong isang element ni A na totoo si P. So para makuha yung opposite truth value, kailangang mapakita ko na sa lahat ng element ni X, hindi totoo si P. Alright? So that means, that's why ito yung negation niya. Okay? So dahil wala akong makitang wala akong makitang x in A na totoo si P. So dapat for all x in A, not P of x. So ganun natin ninegate yung isang existential statement. Okay. Now, and you will see that it is basically a play on negating not only the quantifier but also the predicate involved. And then going back to the 4 types of quantified statements that we have seen earlier, we can make this diagram over here. So for all, this is all x has the property M. All x don't have the property M. There exists an x that satisfies the property M. And there exists no element x that satisfies the property M. So these two guys on the top are what we call contraries of each other. So kapag ang dalawang statements ay contrary to each other, that means that both of them can be false, pero hindi sila pwedeng maging true ng sabay. So contrary ang tawag kapag hindi sila pwedeng maging true ng sabay, pero posible silang maging false ng sabay. Okay. Kasi nasabi nito, for all x, totoo si m. Sabi naman nito, for all x, hindi totoo si m. So they cannot be true at the same time, but they can be false at the same time. Kasi posibleng isa lamang yung nakasatisfy ni m. So false na kagad to. Tapos, for all x element of m, yeah, false na kagad to. Tapos false na rin to kasi hindi lahat hindi totoo si m. Now, subcontraries are statements of this form. So, itong dalawang statements na to ay subcontraries ng isa't isa. Subcontrary statements cannot be, they can be true at the same time, but they cannot be false at the same time. So there exists an m in x, and there exists an x such that not m of x. So posibleng maging totoo sila at the same time. Pero hindi pa sila pwedeng maging false ng sabay. Hindi sila pwedeng maging false ng sabay kasi pagka kinuha natin yung negation, magiging false ito kapag for all x, not m of x. Tapos ang negation nito ay for all x, not m of x, so that will be m of x. So magiging contrary sila ng isa't isa. So hindi sila pwedeng maging false ng sabay. Pero pwede silang maging true ng sabay. On the other hand, the cross statements here, itong dalawa, at saka itong dalawa, notice that they are the negation of each other. When you negate for all x, m of x, nagiging there exists an x such that not m of x. So obviously, dahil negation sila ng isa't isa, magkaiba sila lagi ng truth value. So if this is true, this is false. If this is false, this must be true. So ganun naman sa contradictories. They always have the opposite truth values. And the same goes for these statements on the other diagonal. Okay. So let's see some concrete examples of this. Okay. Okay. So let's see example 21. So let's write the formal negations for the following statements. So for all real numbers, x squared is non-negative. So perhaps we can first write it in terms of, translate muna natin siya into formal statements. So yung formal statement, for example, A ay for all x in R, x squared is non-negative. So x squared is greater than or equal to 0. Then if we want to negate this, okay, so magkakaroon ka ng negation dyan. Oops. Magkakaroon ka ng negation nito. Okay. And when we write the negation, again, para ka lang nag-ooperate. Yung not papasok sa for all, so magiging there exists an x in R, such that maninegate din yung statement dun sa loob. So maninegate din yung x squared greater than or equal to 0. So you can say either x squared is greater than or equal to 0. Okay. Or better yet, gamitin na lang natin yung less than symbol. Okay. So in words, the negation of illustration A is that there exists a real number x such that x squared is less than 0. Or informally, we can say that there is a real number such that whose square is negative. Okay. Okay, so let's try example B. So sa example B naman, okay, ang formal statement niya ay there exists a prime number P such that P is even. So there exists a P in the set of all prime numbers such that P is even. So P is element of E. Remember yung double struct E, yun yung notation natin para sa set of even numbers. Okay. Now, if you want to get its negation, okay, magkakaroon lang to ng not sa unahan, pero yung buong statement. So that means if I translate this, the negation will apply to the existential quantifier. So it will become a universal quantifier. And then it will also negate the statement. P is not even. Okay. And then you can translate it into informal language and say na ang negation ng statement B is that for not R, dapat to ay P. Okay, for all prime numbers, how do we say it in English even more better? So there exists no prime number that is even. Okay. Or every prime number is odd. So you can say it that way. So pag informal, free na kayo to write it in a more elegant statement. Pero in symbol, ito talaga siya. Medyo strict tayo dun sa pagsisymbolize. Okay? All right, so it's already 10 minutes before time. So if you guys need to leave, it's fine. So for those who can stay, let me borrow 5 more minutes to give you more example of this. Para konti na lang yung gagawin nyo sa lab on Monday. Okay. Okay, let's see. Write the formal negations of the following statements. So probably you can do the same thing for example 22. So any volunteer for statement A? Let's see. Oh, Rhea and Rhea. So you want to try A? Nagta-type yata si Rhea. So yeah. Or are you trying to open your mic? See. Oh yeah, sorry Rhea, hindi kita marinig. So you can type your answer in the chat. Let me see. Yeah, chat mo lang Rhea yung answer mo. Let's see who else? Okay, yeah, no problem Rhea. Mary Rose. Nakapag-recite na yata si Mary Rose kanina, no? Lisa, you already also recited. So anybody else? Oh, Elgin. Elgin, nag-recite ka na ba or hindi pa?
Hindi pa po.
Nag-recite ka na rin. Okay. Let's see. Meron bang hindi pa nag-recite na gustong sumagot? Wala na. Sige, Elgin, you want to try? Even though, yeah, nakapag-recite ka na. Example A.
Sir.
Okay,
nasa chat
noted,
box po, sir.
Rhea. Kinuwala yata yung sounds ko. I don't know if Elgin is trying to speak. Pero let's see. Exercise 22A. For all real numbers, x squared is not equal to -1. So formally, we can say that this is the negation would be there exists a real number x such that x squared is equal to -1. So that's going to be the negation, and that is what Rhea type in the chat. That's perfect. Thank you. It's also fine, Elgin. Yeah, hindi ako napag-recite. Sorry, Elgin, hindi ka pa pala nakapag-recite. So let me call you on example B. Go ahead, Elgin.
Sir, rinig po ba ako?
Ayan, narinig na kita ngayon.
So for number B, for all even integers, there is for all even integers, m is not a prime. For all even integer m is not a prime.
Okay, thank you. That's perfect. So negation there exists I for all. So ang set mo ay even integer. So for all even integer x, m is not prime. So yeah, perfect. So that's also correct. Jace, you have a question? You're
Sir,
raising your
hindi
hand.
po ba dapat yung x po magiging m? Since
Oh yeah. Thank you.
and
Lagi ako nasanay ng M, no? So yeah, watch out for those. use the variable that is being mentioned in the problem. Thank you for bringing that up. Okay. Now, I guess there's still a couple of pages left here. Okay. You can read please read the illustration 23. Nandiyan na naman yung sagot. And then in the lab on Monday, I will ask your laboratory instructors to discuss the remaining pages, basically statements with more than one quantifier. Pero basically, it will still rely on the things that we have learned about quantifiers. Yun nga lang, yung mga predicates, pwedeng more than one yung quantifier. For instance, you can say that you might have a statement like this. For all people X, there exists a person Y such that X loves Y. Ang cheesy nung example, no? Or example B, there exists a person Y such that for all people X, X loves Y. So, mas komplikado na ngayon kasi yung statement involves more than one quantifier. So, your laboratory instructors will tell you something about this. They will discuss pages 34 until 36 of the work text. So, that means hindi ko na naman natapos yung coverage ng week 3. Pero I think this is fine. We are still on pace. 3 hours naman yung laboratory nyo. Wag nga lang sana mag-rally yung mga lab instructors nyo. Pero that being said, dahil at least 30 to 60 minutes of your lab on Monday will be spent on discussing the remainder of the study guide, I'll give you a couple more days to finish the worksheet. So pwede nyo siyang pwede kong extend yung deadline until Wednesday right before midnight. Okay? So for worksheet number, is it worksheet number 3? I think so. So yeah, I'll extend it in Canvas. Okay, so I think that's it. We had another fun discussion today. Any questions? Oh yes, Gab.
Sir, ano po kasi off po yung chat ko po. Hindi ko po malalagay na nag-recite po.
Okay, so ano nga yung last name mo?
Dorado po.
Dorado, first name
Gadgel
or
po.
nickname?
Gad po.
Okay. Gad, okay. Yeah, thank
po.
you. So, yeah, those who recited, don't forget to put a comment in the meeting chat. Victor, you have a question?
Sir, I kind of just forgot, sir. They're in the translating part, sir. In exercise 1.3.17.
Uh-huh.
Why in letter A we considered only P to be the set of all positive real numbers when it said all real numbers? What's wrong with just saying all real numbers?
Oh yeah, thank you for that. All real numbers. Yeah, kasi ginamit ko lang siya para ma-define yung set P na ginamit ko dun sa second statement. You see here, you're right. Ang claim ng statement is for all real numbers. Dun sa quantifier ko for all x in R. So for all x in real numbers. Ginamit ko lang yung curly P para dito sa statement na to. So all real numbers, so still x is a real number. So all real number kasi yung requirement. Pero meron daw siyang non-negative square. So yung x squared ay non-negative. So basically, hindi pala non-negative to, no? So, yeah. Hindi pala dapat x in P. So dapat R plus may bilog. Kasi it should be non-negative. Nakalimutan ko si 0 kanina. Alright, so yeah, thank you for bringing that up, Victor. Na nakita natin yung isang mali doon sa sagot natin sa 17A. Okay, is that good?
Okay, sir. Thank you, sir.
So, yeah, that means hindi ko na kailangan yung first sentence. So, hopefully it is just clear that this set, R plus encircled, is the set of all positive real numbers, including 0. Okay. Now, any other questions? Oh, Gabby, you have another question? Or yan ba yung kanina? Okay, kung wala ng questions, yeah, it has been another fun meeting. So thank you for waking up early and joining us today. Kahit magandang warm up to warm up for your day. So I hope you will enjoy the rest of the day. And then, ano nga ba yung nasa spiel ko? Nakalimutan ko, ang aga pa kasi. So let's see each other again on Tuesday. Happy weekend na pala, guys. Bye-bye.
Thank you po.
Thank you, sir.
Thank you,
Thank
sir.